Now that we understood how to check this kind of vulnerability, so we run it again. As you remember, 88, because the first buffer is just 80 bytes, so we're gonna overwrite 8 more bytes, affecting the second buffer, which is gonna be deallocated, and is gonna cause the heap libc corruption detection triggered. So we run it again. We get to the free function. Again, we go just quickly over all the instructions. We get right here, and let me print out the content of EDX. EDX is the object that we are about to free, as you remember. So if we print the content, you can see that here is the beginning of our chunk, but the previous size and the size of this chunk are overwritten, right? Because of our first buffer content. As you remember, we overwrite these 8 bytes with ones. So let's see what's the consequence. We keep executing, and right here we're gonna see that EDX, which is pointing to our chunk, plus 4 is the size. That's gonna be copied into EAX. We see that EAX now is pointing to 31, 31, 31, 31, which is obviously not the size. It's corrupted. Then, if we keep digging, we're gonna execute multiple functions, not related. Here is gonna be the comparison with 16 bytes, as you remember, and then the comparison with 64. We take it because we are above 64, and eventually, what's gonna happen is, if you remember, ECX is gonna try to move to point to the next chunk. In order to do that, it's gonna get the ESI value of our chunk plus its size, which is EDI. As you can see, it's corrupted, and then it's gonna move to that specific offset in memory. When we do that, we can see that ECX is pointing way ahead of the current chunk, or arena is another name that the allocator names all the different chunks. After doing that, eventually we're gonna hit this compare, which is gonna be ECX being compared with EAX. EAX is pointing to something that it is called the top stack. The top stack is the latest stack in that specific arena. That means that after that there are no more space available. So the allocator wants to make sure that we are not using the latest allocations. And therefore it is, there is no problem if it is being used, but if the problem is that if it is being used maliciously. So right here is saying, hey, ECX, are you less or equal EAX? And then it says jump below, but as we know, it's not below, it's way above, it's totally bigger than new size in ECX. So the jump is not taken, and right away the allocator says jump to a problem and report this issue by calling malloc error, which is going to print the corruption in our chunk. We just understood the reason of this detection, how it works. We identify the problem. We understood that the protection works this way. We get our chunk here, and then the next chunk, if for some reason it is overwritten in its structure, when this guy wants to be deallocated, it's gonna try to jump to the next chunk in order to know, to validate the size with the less significant bit to know if the previous chunk is unallocated or not, as you remember. But because of this problem in the overflow, it's gonna point to a totally different way. That is being detected by the allocator, throwing a heap overflow detection error.